Of course, we're going to be focusing on 1 and 2 sample hypothesis testing, but we're going to be focusing on means. But I realized on Wednesday we're not able to finish the one for proportion. So I'm going to quickly talk about 2 sample hypothesis testing for proportion. Then from there, I'm going to introduce you to 1 sample hypothesis testing for mean 1 population, then for means or 2 population. Now let's look at the hypothesis testing of difference of proportions. Before I move forward, some of you have asked me a question about whether the group project is practical aside of, it is, that's why it is called practical. I just want to make that clarification. Okay, so hypothesis testing of difference of proportion. I told you, when we have 2 populations, we want to compare proportions in 2 populations. We're actually going to have the nature of the alternative can be less than, can be greater than, can be not equal. Please, if you want to answer a question on the hypothesis testing, you need to correctly specify your hypothesis. The moment you get the hypothesis wrongly formulated, there's going to be an issue when you want to figure out the p-value. Does that make sense? The p-value, if you want to get a p-value, you need to put into consideration the nature of the alternative. Now, if I want to test for difference of proportions in 2 populations, that is the formula. That is the Z formula. I'm actually going to have, you only need p-cap 1 and p-cap 2 and the sample size n1 and n2. The moment you actually have your Z, the next thing is just to find the probability associated with that. Now the point estimate is p-cap 1 minus p-cap 2 that follow normal distribution. What if I ask you in exam? What is the distribution of the difference of 2 sample proportion? It is that. It follows normal distribution with a difference of P1 minus P2 with no cap, and that guy has a standard error. Take a look at that. And I just told you right now, okay, if you want to get your p-value, you need to put into consideration the nature of the alternative hypothesis. Alternative hypothesis is very, very important. So that you can see that. And the decision is just going to be, we always compare the p-value with the level of significance. The level of significance is the level of statistical error. It's just like telling the world, how many times are you able to mislead them out of 100? Every researcher mislead, including me. But only that, we give, if I give you 5%, it means out of 100, I'm only misleading you 5 times. That's okay. I want to walk you through an example now on difference of proportion. Take a look at this example. Survey USA, okay, pulled 500 Americans and asked if marijuana should be legalized for medicinal purposes. The result of the survey are summarized, as you can see in the table. We have less than 50, we have greater or equal to 50, and you can see their response: legalize, don't legalize. Of course, the question says, use this information to test at the 0.05 level whether younger people are more likely than older people. Look at it, look at that. They're focusing on comparing perception of younger and older. What they're actually referring to, the younger here is going to be less or equal to 50. I mean, less than 50. And what they're going to be referring to older will be greater or equal to 50. Take a look at that. Now, we got assumption. Assumption is that the independent random sample must be at least 5 successes. What do I mean by that? Okay, we're talking about the products must be this. For first population, the product must be at least 5 for the second population. Not only that, what about this must also be this, and this must also be this. But when we're talking about the confidence interval, I think it's greater or equal to 10. But for hypothesis testing, greater or equal to 5. Please take note of that. Now, the population now has been categorized into two based on age, younger, older. Take a look at that. Then you first figure out what is it pickup 1, what is it pickup 2. You know, I needed to give me formula in exam. If you take a look at that pickup 1 now, I need you to tell me, okay, I need you to tell me pickup 1 is x1 over n1. I also need you to tell me pickup 2 is x2 over n2. Before you write that. Does that make sense? Because method is very, very important. Okay, the x1 is 202 divided by, is there anyone who doesn't understand how to understand that proportion? That very proportion now actually represent those who said they should legalize. Because you can see, or you know, the question centered on should it be legalized? What of in another question? Okay, if another question has about whether it should not, then I'm basically going to be using don't legalize section. Does that make sense? Column. Please take notes. Okay, now I'm just going to plug in my, you know, so how do I know? You know, like I said, the very first step is going to be formulate your hypothesis. The non-hypothesis HO is always going to be equality. Does that make sense? HO will always be equality, but the alternative we actually come as alternative can be less than, greater than, or not equal to. If you take a look at the, you know, what I'm presenting now, say more likely, because of that more, alternative is actually going to be greater than, and that was why I put a greater down. Now, you know what I want to do now? I calculate my Z. Do you know that when you calculate your Z, if you really want to get a p-value now, you now need to go back to what we were doing before on a sampling distribution. We want to get the probability of Z greater than that. Why do I say P greater? Why do I say the probability of Z greater? Because the alternative is greater. If the alternative is less than, I'm going to say the probability of P less than. If the alternative is not equal, I'm actually going to say 2 multiplied by the probability of Z greater. Does that make sense? Now, right now, the greater now, whatever I check from the normal table, like I said, I'm actually going to provide normal table in the exam. Whatever table you're going to use, I'll provide that in the exam. Now, you know, whatever you check for, you check is 0.69 from the table under Z, then whatever you check, you're going to subtract from 1. When you subtract from 1, that will give you 0.2451. The moment you get your p-value, then you're going to compare with the level of significance. The level of significance was actually alpha. Okay, this is the rule. When p-value is less than the level of significance, we reject H0. But when p-value is greater, we're actually going to fail to reject H0. In this case, the p-value is actually greater. And when p-value is actually, you know, greater, what do we mean? Then we do not have, you know, when p-value is greater, it means we're going to fail to reject HO. So which means we do not have sufficient evidence to actually reject it. So the conclusion is just going to be, you know, the two age bracket, the younger and the older, they actually have more or less the same perception about whether that should be legalized. Any question? Any question? Now, oh, go ahead. Why not what? You said T-squared? Oh, T-score? Oh, it's going to be Z-score. Anytime you're dealing with proportion, the T is Z. Does that make sense? In proportion, we don't talk about T. Because assumption is that the sample size is large. That's a very good question. Do you understand now? But when we're talking about like, where we're talking about confidence interval, when the population standard deviation is not given, of course, you're going to talk about T-score. Does that make sense now? For the Z, we don't, whether we talk about Z for one population, for two population, whether for hypothesis testing or confidence interval, is always going to be Z score. Does that make sense? That's a good question. Now, I want to quickly welcome you now to that of the mean. We've been testing hypothesis about proportion. We now want to test about mean. We could test about mean for one population. We could test about mean for two populations. Okay, now, if you want to talk about mean, like I said, we're also going to have procedure. Okay, like I said, the basic structure of hypothesis test regarding population mean, do you know is the same as that of the proportion? The same way we stated hypothesis, we started by stating hypothesis. After stating hypothesis, we actually go to computing our test statistic value. And after computing the test statistic value, you know what we do next? We actually get the p-value. And after getting the p-value, we compare the p-value with the level of significance, and we take a decision. Okay, we're also going to do the same, except that what we're going to be specifying under the known and the alternative is what's going to be different. You know, we've been talking about proportion, but this time around, we're going to be talking about mean. Now, let's look at the procedure. Like I said, we're going to be taking random sample. You know, taking random sample is more or less like, since I'm not going to study everybody in the population, I should use instruction of chance in selecting. Okay, I should choose in such a way that anybody in the target population can be choosing, have equal chance of being chosen. So that's what I mean by, and when you're choosing, your sample size also have to be large. We encourage that in research. Now, do you know, when we are testing for one population, I'm testing for mean. This time around, I'm not testing for proportion. I'm testing for mean. Now, take a look at what the non-hypothesis is also going to be equality, right? Equality. What can you see? Can you see that I'm writing mu and mu naught? If you write this, you are wrong. If you write this guy, if you write this by, we are wrong. We don't write sample when we are testing hypothesis. Then under the proportion, if you also write this guy, if you write this guy, you are also wrong. So whether, you know, in hypothesis, you know, we normally focus on the population parameter, not the sample. Does that make sense? When you are specifying, take a look at what I'm specifying now. I said mu. Mu is a population mean. That's a parameter, right? So mu equal to mu naught. The mu naught here is an hypothesized value. Maybe somebody have a claim. You know, somebody can say, okay, you know what, the minimum, the average study hours in the university, you know, of, you know, by University of Minnesota students is maybe 10 hours per week. That becomes an hypothesized value, mu naught. And you now say, oh, no, it can't be that. Maybe you said it is less than that, or you want to say it is greater than that, or you want to say it is not that. Does that make sense? Like I said, investigation is going to follow a claim. Now, in that situation now, we're basically going to use this formula. This is a test statistic. You can see this formula is different from the one we use in the proportion. This is the test statistics. Like my friend talked about T the other time. You can see T now, right? Okay. The only condition, if I want to use T, it means maybe the population standard deviation is not given. And I'm only going to use the sample standard deviation. But let me tell you this. Even here, when the sample size is large, the T becomes Z. Does that make sense? And how large is it large? How large is it large? If it has least story, does that make sense by central limit theorem? Now, if here too, we get the p-value. Okay. Now the p-value can be either that or that, depending on the nature of your alternative. Does that make sense? Please take notes. I want this exam to be walkover for you. Even though if you have not scored A before in statistics, okay, this is the time for you to score A. In fact, you guys are fantastic, you know, from what I've been from what I've been seeing. Now, don't forget the conclusion is always the same in statistics. When you are conducting hypothesis in statistics, when the p-value is less than alpha, you're actually going to reject. When it is greater or equal to alpha, then you're going to fail to reject. Let's take a look at this example. Okay. In the 2004 General Social Study, social survey, men were asked how many hours they worked in a previous week. For the random sample of 895 male workers, the mean was 45.3 hours with a standard deviation of 14.8. Does this data support the claim that the true average numbers of hours the men work each week exceed the standard 40 hour work week? Now take a look at this. When you do one shift, okay, and if you one shift is 8 hours, if you work for 5 days a week, that would be 40, right? 40 hours. Now, this is like testing. Somebody said it's greater than, look at the word exceed. I want you to pay attention to some words. Greater than, exceed, at least, they all go the same way. Okay, as greater than. Okay, now you actually they took a sample of 895. Let me tell you, I told you investigation always follow a claim. They make a claim that, oh, it's going to exceed 40 hours. And I say, okay, are you sure? Okay, I'm going to investigate. And you investigated by taking a random sample of 895 men. And you ask each of them question. Oh, how are you doing? How many hours per week do you work? And I know they're going to give you different numbers, right? If they give you different numbers, you'll find the average, right? Finding the average, that gives you 45.3 hours. That's what you get from the sample, right? With a standard deviation of 40.8. Now we want to test. The very first thing you're basically going to do is to investigate assumption. Okay. Now, the assumption that are very, very crucial is assumption, whether you are taking your sample randomly and if you are working with a normal population. Now, they did not give us any idea about the normal population here, but you know what? The sample size here is large. According to the central limit theorem, even if the population you are choosing from is not normal, but if the sample size is large, how large is it large? 30. Does that make sense? How large is it large? Is this guy. And of course, you have 895 men, then you can boastfully say, okay, the normality assumption is already attained. Okay, now you specify, your hypothesis. Okay, the alternative is going to be greater than because they mentioned exceed in this case. I told you the non-hypothesis HO is always going to be an equality sign. Take a look at that. Now you go to your test statistic. Look at the way you're going to do it. Number one, you talk about assumptions. Number two, the specification of your hypothesis, both HO and HA. And step three, your test statistic value, where you're going to showcase your formula. Then we're now going to be plugging values in. Your X bar is going to be your sample mean. Your mu naught is the hypothesized value. And of course, your S is the standard deviation. And your N is the sample size. The test statistic actually gives 10.7. Now, when you have 10.7, the fact that the sample size is large, I may decide not to even check from T table. Because if I check this guy from T table, the result that I'm actually going to get will be the same as checking from normal table. Does that make sense? Because the sample size is large, what happened in the end? The p-value is very, very small, 0.001. And that very p-value is actually less than any reasonable level of significance. And that was why I said we're actually going to reject HO. So rejecting HO here means, of course, men actually work more than 40 hours. Does that make sense now? Okay, so that is the conclusion. Now, we got possible errors. In fact, I was able to save time today because what I wanted to do on Monday before I can do it now because I still have time. This is going to be the last page on this lecture. Does that make sense? Now, you know, today I've walked you through difference of means. I've walked you through how to test hypothesis about difference of proportions. And I've also walked you through how to test hypothesis about one single mean, but there's something that we haven't done. I'm going to walk you through how to do for difference of means. But before going to the difference of means, I want you to know our model is not perfect. Our model can also mislead. I remember what George Boss said. I don't know whether you've heard about George Boss. You know, George Boss was asked a question whether the model we're using is true. You know what George Boss said? George Boss said, if you mean the whole truth, our model is not true. You know why? Because even though we're trying to capture reality, our model cannot capture exact reality. There's always going to be errors. Okay. Now, in hypothesis testing, we can also make errors. And there are two types of errors that we can make. The first one is a type 1 error, and the second one is a type 2 error. What do I mean by type 1 error? The type 1 error is when HO, the null hypothesis, is true and it is rejected. Maybe the nature has it that it is true. You know, the nature always know the truth, right? If it is true and you reject it, then you've committed type 1 error. Do you know that type 1 error is the same thing as alpha? Type 1 error is the level of significance. Because the level of significance is the maximum probability of committing type 1 error. Okay? Now, type 2 error, on the other hand, is when the null hypothesis is false and it is not rejected. It's like you are accepting the null hypothesis that is false. Okay? We commit this kind of error every day in research. The same way they commit error in the court of law. In the court of law, when under the HO, the accused person is innocent. Under the HA, the accused person is guilty. And according to the law of the state, the accused person is innocent until proven guilty by law. Okay, there was a time I paid a visit to prison, and I've seen a lot of people in the prison, that they did not really commit the offense. They are in the prison because of the error committed by the courts. And do you know, we also have criminals around us. Okay? What do I mean by having criminals around us? Those that are supposed to be in jail, but they are around us because of the error committed by courts. You get what I mean? Imagine if the null hypothesis is true. Okay? The null hypothesis being true is that the suspect is innocent. If that is rejected, that's not good. It means that person will go to jail. Okay, that's an error. What if in a situation where somebody that's supposed to be guilty, the court did not find the person guilty because the court used evidence, and that's why I'm not praying to be involved in litigation. No, in litigation, there's no case that is sure, even if you have all the evidence. Does that make sense to you now? And that's why I don't pray for litigation. Because what if I have all the necessary evidence and the judge could be infallible? The judge can make mistake. And the two parties in litigation, they are not 100% right. I'm going to tell you, no matter how beautiful is your case. And when you have an Anthony, if your Anthony said, oh, you have 100% chance of winning this case, change your Anthony. You can never have 100% chance of winning a case. It's not possible, even if you have all the evidence. And that is why our level of significance can never be zero. Does that make sense? That's why we have 5% level, 1% level. It can never be zero because our model can't capture the word exactly. Now, what do we now want? We want what we call the power of a test. What is the power of a test? What is the power of a test? That's what we want. Power of a test. The power of a test, we're talking about ability to take correct decision. What is the ability to take correct decision, rejecting the non-hypothesis when it is false, accepting the non-hypothesis when it is true? That is the correct decision, which we call the power of a test. That is what you see. Okay, when HO is true and you do not reject it, that's a correct decision. When HA is true, okay, and you reject HO because HA is true, that's another correct decision. But the problem is when you took a conflicting position with the state of nature. We always want our decision to commiserate, to be in agreement with the state of nature. Of course, you know what I mean by state of nature. Nature always knows the truth. Okay, that's what we mean. Okay, give me 1 second. I think I still have a lot of time, and I quickly want to go into another one. Give me 1 second. I think I was able to save time. And do you know,